So today we're going to talk about the remainder theorem and the factor theorem. The remainder theorem states that if you take your factor and set it equal to 0 and solve to find your solution, so let's do that. So x minus 3 equals 0. That's our factor. Set it equal to 0 and solve. Add 3 to both sides. X equals 3. And plug this into your equation. That'll give you remainder. So let's look. So first of all, if I do synthetic division, you take the opposite of this number here. So 3. Bring down your coefficients. 2, negative 5, negative 1. 2, negative 5, negative 1. Bring down my 2. And then I do 3 times 2 gives me 6. Add down. I get 1. 3 times 1 gives me 3. Add down. And I get 2. So my remainder should be 2. So if I plug the positive 3 that I got over here into this equation, I should get 2 out. 2 times 3 squared minus 5 times 3 minus 1. 3 squared is 9, times 2 is 18, minus 15 minus 1 equals 2. So that works. Okay? So that's all your remainder theorem is. It just says if you take the solution to your divisor and plug it back in, you get out your remainder, just like we did over here. Okay, so let's look at some examples. So our first example, if we are dividing, let's find the remainder. Our final result is going to be, what is our remainder? So our remainder is, if we take p plus 6, set it equal to 0, solve for p, we get negative 6. So if we plug negative 6 in here, negative 6 to the 4th minus 5 times negative 6 minus 11 cubed times negative 6 squared minus 25 times negative 6 plus 29. Type that in your calculator. You should get, when you plug negative 6 into the function, you should get out negative 1. So our remainder in this case would be negative 1. So if we divided p to the 4th minus 5p cubed minus 11p squared minus 25p plus 29 by p plus 6, our remainder will end up being negative 1. Okay? Let's get another example. Okay? Again, the first thing you want to do is set your divisor 3x minus 1 equal to 0. Solve for x. So add 1. 3x equals 1. To get x by itself, we got to divide by 3. X equals 1/3. Our final result, we want our remainder. Okay, so we plug 1/3 into this. So 3 times 1/3 cubed minus 4 times 1/3 squared minus 17 times 1/3 plus 6. Type that right into your calculator. And we put 1/3 into the function, you get out 0. So in this case, there's no remainder because your remainder is 0. Okay? So now you pause for a minute and try C. So try to do C on your paper and see if you can figure it out. I'll give you just a few minutes to work on that. Pause if you need to. Alright, so if you plug in 2, right, because when you set y minus 2 equal to 0, you should get y equals positive 2. If you plug 2 into the function, you should get 0. So for C, you should have no remainder. If you're not able to do that yet by yourself, then raise your hand and I'll come around and help you out. Alright, let's look at D. D is the function here. Take 2b minus 3 equal to 0. Get your b by itself, so 2b equals 3. Divide by 2. So v equals 3/2. Sorry about that. Okay, so plug it in. 4 times 3/2 cubed plus 6 times 3/2, that should be squared, minus 8 times 3/2 minus 12. Plug that into your calculator. and you get f of 3/2 equals 3. So 3 is your remainder in this situation. Okay, so we get 3 as our remainder. So that's it for your remainder theorem. So again, all the remainder theorem states is that if you plug in the solution to your factor by setting equal to 0 into the equation, then you get out your remainder. All right, let's look at the next one. The next one talks about our factor theorem. The factor theorem states that if you plug in the solution to your factor, so the opposite of what you have, so -1 here or +3 or -3 here, and get out 0, then that is a factor to your solution. So in this case, if we plug in -1 into our original equation, you get out -4. So that means that x plus 1 is not a factor. Okay? If you plug in -3, in f of -3 comes out to be 0, that means x plus 3 is a factor. And determining a factor or not doesn't really make a whole difference when you're just determining it, but in the future when we start working on other things, it'll make our lives a lot easier knowing what is a factor and what's not. So in this case, they're saying what value of k, so k is right here, would make this a factor. So in order to know this is a factor, when you plug it in, so when you plug in x plus 2 equals 0, x equals -2 when you solve, right? So when you plug in -2 in for x, just like so, if you plug in -2 for x, you should get 0 out, right? That determines that we have a factor. So -2 cubed is -8. -2 squared is 4k minus 2 plus 6. So we get 4k minus 4. This is all equals 0, equals 0. Add your 4. 4k equals 4. So k equals 1. So if we put 1 in for k, that'll make this our factor because that makes it equal to 0. So k would have to be 1. And you can always plug it back in. You can make k 1 and then try it out and see if it works, and it'll show you that it works. All right, so last thing says if we divide x minus 3 into this function right here, we get a remainder of 2, which means that if we put positive 3 into this function, we get 2. So let's try that out. 3 cubed plus 4 times 3 squared minus 2 times 3 plus k gives us -2. So how do we find k? Well, 3 cubed plus 4 times 3 squared minus 2 times 3 gives us 57 plus k equals -2. So we subtract our 57 and k equals -59. Okay? So now that we know k, the next question is, what is the remainder when you divide it by x plus 2? So I'm going to change it up here real quick. This becomes, we found out that k is now -59. So that's our new function. We have to plug in a -2 to find this remainder. So we would say -2 cubed plus 4 times -2 squared minus 2 times -2 minus 59 would give us the remainder. And when you plug that into your calculator, you should get -47. And so the remainder is -47 if you divide this function up here by this divisor. Okay, if you're still confused, still lost, please let me know and I'll come around and help you. If you feel like you've got this stuff down pretty well, flip it to the back of your page and start working on your homework assignment.